Hi everyone, we're going to continue on with our lesson. And now we're going to be switching gears a little bit by talking about a different type of angle, and that is called a radian angle. So angles can be measured in degrees as well as radians. So the question is, what is a radian? And a radian is a part of a circle. It has a radius that is centered at the origin, and 1 radian is the measure of an angle in standard position whose terminal side intercepts an arc length that is the length of the radius. So that's what this picture shows right here. We have ourselves 1 radian, and we have our length of the radius. And 1 radian is the angle that is created where it intercepts a length or an arc that is the length of the radius. It sounds very complicated, but it comes from, believe it or not, it comes from circumference. Radians are just parts or pieces of the circumference. So we know that the formula for circumference is equal to 2 pi r. So that means that there are 2 pi radians in a full circle. So that's where that comes from. So I don't want you to think too much about it. Essentially, ladies and gentlemen, a radian is another way of expressing an angle. So there are 2 ways to express an angle, and radian is just another way to write an angle. And it is derived from the circumference, so it's talking about how far along the circumference is your angle. How wide is it with respect to your circumference is your angle. That's all that it's really talking about. And we learned last year when we were studying circles that whatever the measure of the angle is the same exact measure as the arc. That's getting a little bit more complicated and a little bit more in depth in what we need to really look at. But an angle is just how far along the circumference are you. And we have ourselves 2 pi radians is equivalent to 360 degrees. So if you were to travel 2 pi, you would land at 360 degrees. So therefore, halfway or half of 2 pi is 1 pi, and half of 360 is 180. So therefore, pi radians, not just the number pi, but pi radians represents 180 degrees, and 2 pi radians is equivalent to 360 degrees. This is something that I want you to please make sure that you know and that you study. That's very, very important. So we can convert between degrees and radians because they will represent the same exact angle. We can represent angles using both degrees and radians. So let's say that you wanted to convert degrees to radians. Well, you would multiply your degree by pi radians over 180 degrees. And let's say that you want to go from degrees back, or from radians to degrees. You would multiply your radian by 180 degrees divided by pi radians. So essentially, whatever you want will be on top. So that's the way that you remember this. What you want it to become, so whatever you want, will be on top. And whatever you want to get rid of will be on the bottom. So that's the way to remember it. These 2 formulas, I need you guys to please make sure that you know and study. All right, let's go ahead and look at example number 3. Example number 3, we want to convert 315 degrees to radians. So we want to figure out how many radians, how many pi's, or how many portion Or what proportion of 2 pi is 315 degrees? So that's what we need to identify. So what we're going to do is we're going to take 315 degrees, since we're going from degrees to radians, we're going to take 315 degrees and we're going to multiply it by what we want. And I'm going to multiply it by pi radians divided by what I want to get rid of, which is degrees, by 180 degrees. When I multiply straight across, I'm going to end up with 315 pi radians divided by 180. 315 and 180, we can simplify that to 7/4. So you can use a calculator in order to do that, but it'll simplify to 7/4 pi, or 7 pi over 4 radians. So 315 and 180, they both are divisible by 5. You can just start simplifying it, or you can use your calculator tricks that you've learned along the way. All right, the next one, letter B, let's say that we want to, letter B, we want to convert negative 50 degrees to radians. So negative 50 degrees will probably end up with negative radians. So I'm going to take negative 50 degrees and I'm going to multiply it by pi over 180 degrees. So pi radians divided by 180 degrees. Multiplying straight across, I have negative 50 pi radians divided by 180 degrees. And negative 50 over 180, that is equal to negative 5 pi over 18 radians. And that is your answer. Let's go ahead and look at example number 4. Let's say that we want to go convert pi over 6 radians to degrees. So I'm going to take my radian measure, which is pi over 6, and multiply it by what I want. I want it to be in degrees, so 180 degrees will be on top, divided by pi radians. So the pi's in this case will cancel out, and we will be left with 180 degrees divided by 6. And 180 degrees divided by 6, that's going to be, and the radians will cancel out, excuse me. 180 divided by 6 is going to be equal to 30 degrees. And finally, we want to convert negative pi over 12 radians to degrees. So I'm going to take negative pi over 12, and since I want to turn it into degrees, I'm going to put 180 degrees on top, divided by pi radians. And since this is already radians, I forgot to write down the radian over here. So that's why the radian canceled out. So over here, I need to write radian. So the radian will cancel out, the pi will cancel out, and we'll be left with negative 180 degrees divided by 12. And negative 180 divided by 12, that is equal to negative 15 degrees. So negative 15 degrees is equivalent to negative pi over 12 radians. Okay, so now there exists, we're looking at our unit circle coming together. Now on your unit circle, there's going to be radian measure, there's going to be degrees, and there's going to be ordered pairs. We have not talked about ordered pairs yet, but this is the beginning pieces of our unit circle. So the diagram shows the equivalent degrees and radian measures for the special angles from 0 to 360 degrees and from 0 to 2 pi. Let me make sure that we're on the same page. Sorry about that. So that's what we see here. So that's what the circle is all about. We have going from 0 to 360 degrees and 0 to 2 pi radians. Now, what your job is you need to memorize the equivalent degrees and radian measures at least in the first quadrant. Because if you know the first quadrant through 90 degrees, you can find all other special angles by using the multiples of these angles. And this is something that we're going to be working on actually in class. So I will be doing something kind of special with you guys in class when I see you. We're going to be talking about how to identify all of those angles, and we'll be working with this again with the unit circle when I talk about how to talk about the unit circle. But the thing that I want you guys to keep in mind is this. So looking at this picture, So I'm just going to zoom it in. We're going from 0 all the way to 2 pi, from 0 degrees all the way to 360. And so as long as you know the first quadrant, and I'll talk really quick about what I plan to go over in class. Essentially, 30 degrees is equivalent to pi over 6. So every 30 degrees is another pi over 6. So that means 30 degrees plus another 30 degrees is 60 degrees. So pi over 6 plus another pi over 6 is 2 pi over 6. And 2 pi over 6 is pi over 3. If we were to travel another 30 degrees, we would end up at 90 degrees. So we would have 2 pi's over 6, 3 pi's over 6. 3 pi's over 6 is 1/2. That's exactly what we have here. Traveling another 30 degrees, we have traveled 1, 2, 3 pi's over 6. I'm sorry, excuse me. Pi over 6, 2 pi's over 6, 3 pi's over 6, 4 pi's over 6. 4 pi's over 6 simplifies to 2/3. 5 pi's over 6 is now 150. 6 pi's over 6 is 100. Is 6 pi over 6? That's going to be pi. 7 pi's over 6 is traveling another 30 degrees. We have 7 pi's over 6. Traveling another 30 degrees, we have 8 pi's over 6, which simplifies to 4 pi's over 3. And then we have 9 pi's over 6, which simplifies to 3 pi over 2. So all I'm showing here is that if you were to add just pi over 6, every 30 degrees being another pi over 6, you can simplify and end up with your radian measure. So all you would really need to know, truly, is that 30 degrees is pi over 6. The same thing is true with 45 degrees. Every 45 degrees is another pi over 4. So if we were to travel 45 degrees and land at 90, 2 pi's over 4 is pi over 2. Then 3 pi's over 4. Then 4 pi's over 4 is 1 pi. 5 pi's over 4, 6 pi's over 4. 6 pi's over 4 is 3/2. 7 pi's over 4, and then back up here, 8 pi's over 4 is 2 pi. You can also make this work with 60 degrees. 60 degrees is pi over 3. Every 60 degrees that you travel will be another pi over 3. So here's 60 degrees, 120 degrees. We have 2 pi's over 3. Then we have 3 pi's over 3, which is which is going to be pi. 4 pi's over 3 is 240. 5 pi's over 3 is 300. 6 pi's over 3 is 2 pi. So every 60 degrees, we're adding an extra pi over 3. Then we have pi over 2 is 90 degrees. So every 90 degrees is a pi over 2. So another 90 degrees would be 2 pi's over 2, which is 180. 3 pi's over 2, and then finally 4 pi's over 2, which is 2 pi. So all I did here was just travel around the entire circle, adding however many degrees or however many radians that we're actually talking about. And that's how you identify your radian measure, using a circle. Or you can just work with some formulas. So for example, let's talk about 30 degrees. If we want it, we know that 30 degrees times 5 is equal to 150. So since 30 degrees matches up with pi over 6, pi over 6 times 5 will be 5 pi's over 6. So if we were to go to where 150 is, look at there, it's 5 pi's over 6. So the whole point of this is that there's going to be patterns, and I want you to constantly be looking for shortcuts and patterns for filling out the unit circle or working with degrees and radian measure. That would probably be the best approach. Just constantly be looking for shortcuts and patterns. We're now going to be doing the same exact type of problem that we did in the last video, and that's where we're going to draw an angle with the given measure in standard position, and then we're going to find one positive coterminal angle and one negative coterminal angle. If your problem starts off in radians, it must end in radians. And if you are working with radians, I am going to look for, did you label your axes using radians? So please get into the habit of knowing where what each of the labels are going around a coordinate plane. So since we're working with radians and this is a positive radian measure, I'm going to start off with 0, and then 90 degrees is pi over 2. So every 90 degrees is a pi over 2. Then we have pi, then 3 pi over 2, and then 2 pi. So 9 pi's over 2. All I'm going to do is travel I'm just going to count pi's over 2, and I want to have 9 pi's over 2. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So here is 9 pi's over 2. I forgot to draw my initial side, so let me make sure that I draw my initial side. And I'm now going to land right up here at 90 degrees. So 90 degrees is a pi over 2. So I've just drawn this angle in radians, and now we need to come up with some coterminal angles that are positive and negative. So one positive angle, if we were to go into a positive direction, so if I were to travel in a positive direction, my positive angle would be pi over 2. So pi over 2 would be equal to my positive coterminal angle, because that's where I landed. It's going to be positive. One approach is you could just simply subtract 9 pi. So in order to get this, you could go 9 pi over 2 minus 2 pi. And now 2 pi is essentially 4 pi's over 2. So we have 9 pi over 2 minus 4 pi's over 2, and that is equal to 5 pi's over 2. 5 pi's over 2 is also another positive coterminal angle. Now we only needed to find one, but that is also a valid answer. But let's say that we wanted to keep going, so I'm going to do 9 pi's over 2 minus, instead of 4 pi's over 2, we're now going to double that to make that 8 pi's over 2. And subtracting, we will end up with pi over 2, which is still a positive answer. You could also add 2 pi. If we were to add 2 pi, we would end up with 13 pi's over 2. 13 pi's over 2 would still be another positive answer. So now what we want to do is we want to find a negative coterminal angle. So to find a negative coterminal angle, we would subtract another pi over 2. So this represents 1 pi over 2. 8 over 2 represents 4 pi over 2 represents 2 pi, one revolution, or one time around the circle. 8 pi's over 2 represents 4 pi. That means that we went around the circle twice, and we still landed at a positive answer. So now what we want to do is we need to come up with a negative answer. So that means that not only do we need to go around the circle or subtract away 2 pi's or 4 pi, we now need to subtract another set of 2 pi, which is 6 pi. 6 pi is equivalent to 12 pi's over 2. So now I'm going to go 9 pi. Does that make sense? Yep. So 9 pi over 2 minus, I need to subtract away 3 times 2 pi, which is 6 pi. So that's 9 pi over 2 minus 6 pi, and I need to change that to have a common denominator of 2, so that's 9 pi over 2 minus 12 pi over 2, and that's going to be equal to negative 3 pi over 2, which hopefully that makes sense to you. If we were to travel in a negative direction, we're going to be traveling not just negative pi over 2, negative pi, negative 3 pi over 2. So you didn't have to show all of that work in order for you to get this answer. You could just use the picture in order to come up with that answer. But the goal is to get 1 positive and 1 negative, and I came up with 2 positive coterminal angles and 1 negative. As long as you have at least one of each type, that's perfectly fine. Let's go ahead and look at letter B. So for letter B, we have 7 pi's over 5. Well, unfortunately, pi's over 5 is not anything special that we're going to be working with. So therefore, I strongly recommend, just to get an idea of where we're supposed to be, 7 pi's over 5, if you were to put 7/5 into your calculator, that would be approximately 1.4. So that is 1.4 pi. So 1.4 pi. So I'm going to label my axes. I have 0, pi over 2, pi, 3 pi's over 2, which is 1.5 pi, and 2 pi. So 1.4 pi is kind of close to 3/2. So here's my initial side. We're going counterclockwise, and it's going to be kind of close to 3/2. So there's my angle right here. So that's my original angle. Now I need to come up with another coterminal angle. So since this is, we didn't have to spin around the circle very much. In order to find a positive coterminal angle, not only are we going to have 7 pi's over 5, but we're going to spin around the circle 1 full times plus another 7 pi's over 5. So we spun around the circle 1 full time, so that's 1 full 2 pi plus another 7 pi's over 5. So that's what I'm going to do here. I'm going to take 7 pi over 5, and I'm going to add 2 pi. So this is really 7 pi over 5 plus, this is going to be changing my denominator to be 5. That's going to be 10 pi over 5 to get 17 pi over 5. And that represents my positive coterminal angle. So if we were to travel 17 pi's over 5, we would end up at this location. To find your negative coterminal angle, we're going to subtract. So I'm going to take 7 pi's over 5, and I'm going to subtract away 2 pi, and that'll give me a negative number. So I'm going to write 7 pi over 5 minus 2 pi. So that is 7 pi over 5 minus 10 pi over 5. And that equals negative 3 pi over 5. Sorry, guys. So that represents negative 3 pi over 5. And if we were to travel around the circle, if you think about it, since 10 pi's over 5 represents 2 pi, and we're going by pi's over 5, we're 3 units away from it being 10. If you can see patterns and shortcuts, that's perfectly fine. But our negative coterminal angle in this case is negative 3 pi over 5. So that is the introduction to radian measure. I know that it's not necessarily the easiest information, but I want you to be very familiar with this picture up here. I want you to work with the radian measures. I want you to just approximate where they are at. Try to get used to the fact that 2 pi radians represents 360 degrees, and that pi radians represents 180 degrees, and so on. Essentially, like I said to you before, if you have your first quadrant memorized, then you can solve any of these problems. Please email me if you have any questions over anything. Otherwise, I will see you in class.